This is SpaceTime Series 24, Episode 48. Coming up on SpaceTime, SpaceX Starship to be the next lunar module, the secret to Jupiter's strange auroral activity, and the mysteries of extremely luminous infrared galaxies. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA has selected SpaceX to provide the lunar landers that will carry both crew and cargo between the Lunar Gateway space station and the Moon's surface. SpaceX won the $2.9 billion contract over Blue Origin and Dynetics to provide the reusable shuttle service using its Starship spacecraft, which is now undergoing early prototype testing in Texas. Starship is the culmination of SpaceX boss Elon Musk's dream to develop a fully reusable super heavy lift spacecraft capable of carrying 150 tons of people and cargo into Earth orbit and 100 tons on missions from Earth to the Moon, Mars, and interplanetary journeys across the solar system. Put simply, Musk sees Starship as a colonial transport system. Technically, Starship's simply the upper stage of a gigantic two-stage launch system. The 230-ton first stage, called the Super Heavy, is 68 metres long, 9 metres wide, and constructed out of stainless steel. It's powered by 37 liquid methane and oxygen-propelled Raptor rocket engines, providing 72 meganewtons or 16 million pounds of thrust. The 120-ton upper or Starship stage is 50 metres long, also 9 metres wide and constructed out of stainless steel, and powered by 6 of the same liquid methane and oxygen propellant Raptor rocket engines. Starship is equipped with its own retractable landing gear, allowing rocket-assisted vertical landings. That's what they've been trying to perfect in Texas of late. SpaceX ultimately plans on using the Starship Super Heavy launch system to replace the company's existing Falcon 9 and Falcon Heavy launch systems, as well as its Dragon capsules. The Starship Human Landing System, or HLS, is a variant being designed to stay on and around the Moon, so it won't require the heat shield or air brakes, which are an integral part of the main Starship design. The Starship HLS variant will use high-thrust Methalox reaction control system thrusters located mid-body for the final tens of metres of terminal lunar descent and landing. It'll also include a smaller crew area and a much larger cargo bay, and equipped with solar arrays located on its nose below the docking port. SpaceX intends using the same high-thrust reaction control system thrusters for liftoff from the lunar surface. The current plan calls for the Starship HLS to be launched into Earth orbit using the Super Heavy booster, and will then use a series of tanker spacecraft to refuel the Starship HLS vehicle for the lunar transit and lunar landing operations. NASA's Artemis project will see the Artemis 3 mission launch in 2024. It'll carry 4 astronauts in an Orion spacecraft aboard the agency's new SLS heavy lift rocket on a 30-day mission to the Moon, ultimately returning humans to the lunar surface. But Orion won't go all the way to the Moon. It'll only take crew to the first modules of the Lunar Gateway space station. Gateway will act as a staging post for missions down to the lunar surface. 2 crew will remain on station, while the remaining pair will use Starship to travel from Gateway down to the lunar surface for a 6-day stay. They'll then use Starship to fly back to Gateway, where they'll then rejoin their colleagues and take Orion back to Earth. However, if Gateway isn't available in time, Orion could dock directly with Starship. Last year, SpaceX became the first private company to successfully send a crew to the International Space Station, in the process restoring America's capability to fly humans into space from American soil, an ability lost with the mothballing of the Space Shuttle fleet following the STS-135 mission in July 2011. Of course, humans haven't been to the Moon since the Apollo program ended in 1972. NASA plans to establish a sustainable presence on the lunar surface, using Gateway as a staging post and to pave the way for future manned missions to Mars in the 2030s. This is SpaceTime. Still to come, the secret to Jupiter's strange auroral activity and the mysteries of extremely luminous infrared galaxies. All that and more still to come on SpaceTime. New computer models suggest that Jupiter's spectacular auroral displays are unique in the solar system, with a mix of different types of magnetic field lines. The findings, reported in the journal Science Advances, suggest that Jupiter's polar caps are threaded in part with closed magnetic field lines, rather than with entirely open magnetic field lines, as is the case with most other planets in the solar system. Open lines are those that emanate from the planet but trail off into space away from the Sun instead of reconnecting with a corresponding magnetic field line from the opposite hemisphere. On Earth, the aurora borealis and aurora australis, the northern and southern lights, appear on closed field lines around an area referred to as the auroral oval. It's a high-latitude ring near but not at each end of Earth's magnetic poles. Within that ring on Earth and on some other planets is an empty region referred to as the polar cap. It's where magnetic field lines stream out unconnected and where auroral activity rarely appears because of it. Think of it like an incomplete electrical circuit at home. No complete circuit, no lights. But Jupiter has a polar cap in which the aurora dazzles and which has therefore puzzled scientists. One of the study's authors, Peter Delamere from the University of Alaska Fairbanks, says the problem is researchers were too Earth-centric in their thinking about Jupiter because of what they had learnt about Earth's own magnetic fields. The arrival at Jupiter of NASA's Juno spacecraft in July 2016 provided images of the polar cap and aurora. But those images, along with some captured by the Hubble Space Telescope, couldn't resolve disagreement among scientists about open magnetic field lines versus closed lines. So Delamere and colleagues used a newly developed global magnetohydrodynamic computer model of Jupiter's magnetosphere to show a largely closed polar region with a small crescent-shaped area of open flux accounting for only about 9% of the polar cap region. The rest was active with aurora, signifying closed magnetic field lines. So it turns out that Jupiter possesses a mix of open and closed field lines at its polar caps. Now, if the models are correct, it raises all sorts of questions about how the solar wind interacts with Jupiter's magnetosphere and how it influences the dynamics. Jupiter's aurorally active polar cap could be due to the rapid rotation of the planet once every 10 hours compared to Earth's 24-hour rotation. Or it could simply be due to the enormity of its magnetosphere. Both work to reduce the impact of the solar wind, meaning the polar cap magnetic field lines are less likely to be torn apart and become open lines. And then you've got to ask, to what extent does Jupiter's moon Io affect the magnetic field lines within Jupiter's polar cap? See, Io is electrodynamically linked to Jupiter, something unique in our solar system, and as such is constantly stripped of heavy ions by its parent planet. So for now, the jury's still out on the magnetic structure of Jupiter's magnetosphere, and exactly what its aurora is saying about its topology. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
New insights into what's happening around Jupiter.
Yeah, the thing that has been puzzling about Jupiter's aurorae is that unlike the Earth, the aurorae occur over a broad area of Jupiter's polar caps. So let me just unpick that a bit, to use a modern term, which I don't like really. Let me explain it a bit. On Earth, the aurorae occur in what's called the auroral circle, which really, or the auroral oval is actually what it's called, which explains it all. So they don't happen at the magnetic pole itself. They happen in a ring around the magnetic pole, centered on the magnetic pole. That's where the aurora are at the strongest. It's a sort of naive explanation, but this is kind of the case. The reason for that is to do with the magnetic field lines of the Earth's magnetic field. And I guess we're all familiar with what happens to iron filings when you've got a bar magnet. You put the bar magnet down and the iron filings trace out the magnetic field. And the field lines normally run from the North Pole round the outside and come back into the South Pole. And they are called closed field lines because they're closed. Both ends of them are on the magnet. Same with the Earth. But there are what are called open field lines as well, which are field lines that just head off into space. And you can sort of imagine that that will be the case. And so the open field lines are the ones inside the auroral circle. And so that's why you don't see aurorae there, because the subatomic particles from the sun are not spiraling down like they do in the auroral oval region and lighting up the atmosphere by exciting the atoms of the atmosphere. So that's why it's an auroral oval, because of where the field lines actually go into the Earth. Now, Jupiter is different, because apparently on Jupiter you get aurorae within the whole of the polar cap. It's not just within that auroral circle. And this is until now has been the puzzle. And there is some new research which seems to shed light on it. And it comes from a number of institutions, including the University of Alaska, Fairbanks Geophysical Institute, and the University of Hong Kong. A number of collaborations, actually 13 researchers, I think, have made this key discovery about the aurora. Once again, it depends on theoretical models. The theory is that aurorae only occupy this zone where the magnetic field lines actually close up and disappear into the Earth, and not elsewhere. But the new theory that these scientists have propounded is essentially one that says the aurorae can actually occur elsewhere. They can occur in open field lines. So what they've done is used computer modelling to help. Their research revealed a largely closed polar region. That means where the field lines are going back into Jupiter, with a small crescent-shaped area of open flux. That means where the field lines are going out into space, accounting for only about 9% of the polar region. And the rest was active with aurora, signifying closed magnetic field lines. But Jupiter, it turns out, possesses a mix of open and closed field lines in the polar caps. And Dr. Delamere made this comment: there was no model or no understanding to explain how you could have a crescent of open flux like this simulation is producing. It just never even entered my mind. I don't think anybody in the community could have imagined this solution, yet the simulation has produced it. To me, this is a major paradigm shift for the way that we understand magnetospheres. That's the magnetic region around planets. It raises many questions about how the solar wind interacts with Jupiter's magnetosphere and influences the dynamics. So basically, you've got a situation quite different from the Earth, and what they're putting that down to is possibly the rapidity of Jupiter's rotation, because Jupiter goes around once every 10 hours, Andrew, compared with our once in 24 hours, plus the fact that you've got this enormous magnetic field around Jupiter, so in a very, very large magnetosphere. And so what they're suggesting is that they reduce the impact of the solar wind. It means that perhaps the magnetic field lines are more likely to be closed up on Jupiter. There's another thing about Jupiter, though, that's weird, and we know that this comes about because of spacecraft measurements, but Jupiter's moon Io, which is the innermost moon, highly volcanically active, it's kind of electrically linked to Jupiter because you can see transfer of material between along the magnetic field lines from Io to Jupiter itself, in fact to the polar cap. So there's all kinds of complexities there, but at least there is something that is better understood because of this theoretical model of Jupiter's magnetosphere.
You talk about the magnetic field of Jupiter, and obviously trying to think of Jupiter the way we think of Earth was probably always going to run us into a brick wall, because they're very, very different planets. Is Jupiter's magnetic field generated in a different way to that of Earth?
We think it's probably the same, but you're absolutely right to focus on that, because we don't know what's at the middle of Jupiter. The Earth's magnetic field is generated by the iron core, and that seems to be likely that something like that will be at the middle of Jupiter, but it might not be iron. Some people postulate that Jupiter has a core of metallic hydrogen. Work that one out. Hydrogen that's turned into a metal, which would be conducting. So, that might also generate the magnetic field. But honestly, we don't know. Juno, the Juno spacecraft, which is still active around Jupiter, one of its tasks is actually probing the innermost secrets of Jupiter in terms of its core, if it has one, if it has a solid core. We don't even know that it has a solid core, but it seems likely, given this magnetic field, that's got to come from somewhere. So we might know more when Juno's mission is finished. I mean, there are probably papers that are coming out on this now that I haven't really been keeping up with, but it's probably our best assistance to understanding what's going on with Jupiter is the Juno spacecraft.
Yes, indeed. All right. Well, it's taken a while, but we've suddenly decided we need to treat Jupiter like something that it's not akin to Earth, which makes sense. I mean, we're a rocky planet. It's a gas giant.
Yeah, I know. It's what is
not
it? 11
even closely related second cousins twice removed.
Yeah. What it has in common is it was made from the same cloud of gas and dust. So you kind of know what it's made of, but you don't know how that's distributed within Jupiter.
Yeah, we don't know what lies beneath, but some fascinating findings.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is SpaceTime. Still to come, the mysteries of extremely luminous infrared galaxies. and a final hot fire test for one of the world's most powerful rocket engines. All that and more still to come on SpaceTime. Astronomers have observed an extremely luminous infrared galaxy during a unique point in its evolution. The findings, reported on the pre-press physics website archive.org, are providing important insights into the process of galaxy formation and evolution. Extremely luminous infrared galaxies are massive galaxies exceeding 100 trillion solar luminosities, with much of that energy being in the infrared part of the electromagnetic spectrum, possibly because of activity around the central supermassive black hole, known as an AGN or active galactic nuclei, or from star formation, or from both. The galaxy, known as WISE J090924.01 plus 000211.1, was part of the Aerojet Final Equatorial Depth Survey. Aerojet is a German X-ray space telescope instrument aboard the Russian Spectre RG spacecraft. Combined with archival data from NASA's Chandra X-ray telescope and the European Space Agency's XMEM Newton X-ray space telescope, the results indicate that this galaxy has some 500 billion times the mass of the Sun, with a monster supermassive black hole at its centre of some 7.4 billion solar masses. The data also suggest that this galaxy is producing some 3,850 solar masses of new stars every year. Now, by comparison, our own galaxy, the Milky Way, is some 3 times more massive, but it has a far smaller black hole, and it's producing just one new solar mass star a year. Astronomers believe what they're seeing in this distant galaxy is a short-lived phase in the galaxy's evolution, during which it's embedded in a large amount of gas and dust, with hydrogen being blown outwards along the line of sight, and warm and hot gas still being heated by the active galactic nuclei. This is SpaceTime. Still to come, a final hot fire test for the world's most powerful rocket engine. And later in the science report, the dangers of too much energy drink. All that and more still to come on SpaceTime. The world's most powerful hydrogen-fueled rocket engine, the Aerojet Rocketdyne RS-68A, has completed its final ever hot fire acceptance test at NASA's Stennis Space Center in Mississippi. The United Launch Alliance have just 4 remaining Delta IV Heavy missions slated before the launch system's retirement. The Delta IV, together with the Atlas, is being replaced by the new Vulcan launch vehicle. The RS-68A engine is used in each of the 3 side-by-side mounted core stages which make up the United Launch Alliance Delta IV Heavy launch vehicle, providing a total of more than 2 million pounds of thrust. The RS-68A is based on the earlier RS-68, which was used on the original single-core Delta IV rocket, which undertook its maiden flight back in 2002. The RS-68A was introduced on the Delta IV Heavy in 2012. Each RS-68A engine is rated at some 705,000 pounds of thrust. Now, by comparison, the Aerojet Rocketdyne RS-25 Space Shuttle main engines, 3 of which were used on each of the orbiters, and 4 of which will be used in the first stage of the new SLS moon rocket, are each rated at 512,300 pounds of thrust. But of course, they're reusable. By the way, the most powerful liquid-fueled rocket engine ever developed was the Rocketdyne F1, 5 of which were used on the first stage of the Saturn V Apollo moon rocket. Each F1 engine was rated at over 1.5 million pounds of thrust at sea level and almost 1.75 million pounds in space. This is SpaceTime. And time now to take another look at some of the other stories making news in science this week with a science report. A new study has confirmed that wearing 2 masks really is better than 1. The findings, reported in the Journal of the American Medical Association, compared the filtering efficiency of a single-face mask versus double masking. The authors found that on average, a single-face mask had a filtering efficiency of 55%, while doubling up increased that efficiency to an average of 66%. Just using a single mask, efficiency was generally higher for medical masks than commercial cloth masks and bandanas. But the combination of wearing a medical mask beneath a cloth mask provided the best protection. More than 3.1 million people have now been killed by the COVID-19 coronavirus, and more than 150 million have been infected with the deadly disease since it first emerged in Wuhan, China, and was spread around the world. A new study warns that some tropical fish species are already finding the ocean too warm and are fleeing the equatorial region for cooler waters. A report in the Proceedings of the National Academy of Sciences looked at how 48,661 marine species have been distributed since 1955. Consistent with previous research, the new study has confirmed a dip in marine biodiversity around the equator, showing that biodiversity is already being threatened by climate change. The studies also found that species loss has worsened since the 1970s, meaning the equator is already far too hot for some species to survive. Archaeologists have uncovered what may well be the world's earliest known map. The intricately carved 4,000-year-old early Bronze Age stone slab measures some 3.86 by 2.1 metres across and dates from between 2150 and 1600 BCE. It was found in France's Luan parish with an early Bronze Age barrow back in 1900 and taken to a private museum. It was then acquired by France's National Antiquities Museum in 1924 and placed into storage, moved from cellar to cellar until finally being properly examined in 2017. A report in the Bulletin of the Society of Prehistoric France claims the slab is a cartographical representation of part of the Odette River Valley. A man who regularly drank 2 litres of energy drink a day has ended up being hospitalised for 58 days with heart and renal failure. A report in the British Medical Journal says the case supports growing concern around the risks posed by energy drinks. The 21-year-old presented to hospital with shortness of breath and abdominal swelling, and tests revealed heart and kidney failure severe enough that the hospital considered a dual organ transplant. He had no significant past medical, family or social history, indicating his condition was likely linked to his high energy drink consumption. And finally for this week, despite all their ongoing efforts and hard work, despite all the howls, branch beatings, rock throwing, eyewitness reports, muddy footprints, blurry squatch blobs, and even the occasional hairy hominid-looking creature in the distance, the team at Finding Bigfoot were never able to actually find a real-life Sasquatch. No remains, no graves, no roadkill, and no identifiable DNA. And it's a sad thing, because indisputable scientific proof of the existence of Sasquatch will be one of the most important scientific discoveries of all time. But Tim Mendham from Australian Skeptics says all is not lost for intrepid Bigfoot cryptozoologists out there.
I'm still a big fan of Finding Bigfoot, but they're so close. I'm the sort of person who's been to Loch Ness. I've been there 3 times, and
Oh, have you?
Still haven't seen it.
Really?
Oh, yeah.
Okay.
Fabulous place. Yeah, I like Loch Ness. It's a very pretty place, actually. You get a nice chops at a certain pub on the other side of Loch Ness where no one goes to. But, I haven't been there a lot. I've been to all sorts of places. Go up in the Blue Mountains near Sydney to try and find a yowie or even a black cat. All sorts of things. But, yeah, finding a Bigfoot would be great. So there's a film coming out in America, of course, and it's called 15 Things You Didn't Know About Bigfoot. And basically it's a a mockumentary, right, about some investigators who go out and try and find out about Bigfoot, etc., and find it and have major problems, including they have a very strange guide who's trying to show them the way to go, and he turns out to be a bit probably weirder than a Bigfoot would be. So it's a humorous thing. It's a mockumentary. It's supposed to be coming out in a few months' time. You'll probably be able to stream it, whatever, but it's fun. And it makes fun of Bigfoot hunters, which is cruel, because most of them are probably decent people who are desperately trying to find something which hasn't been found yet, and they will grab onto any evidence they can as proof that these things exist. As you say, breaking a twig in the forest is evidence of Bigfoot being around. You always love those programs you see on TV, with everyone's being filmed at night with infrared cameras.
Yeah, they're always wearing camouflage for some reason.
Yeah, no, I can't understand that either, actually. Ghost hunters wear camouflage too. They wear sort of jungle greens. You think, what are you hiding from?
Maybe they all shop at the same place.
It's a ghost. None of the ghosts are going to worry what you're wearing. These sort of scary things with noises in the distance, etc. Obviously indication of Bigfoot, but it's fun. This film is making fun of that.
That's Tim Mendham from Australian Skeptics. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.